We're going to start off section 1 of chapter 10 with a little bit of review with function notation. We have a function here of your input squared minus 3 times input. Remember, when you're looking at this, all that means is what's in your parentheses is what goes in for your x. Once again, our rule is input squared minus 3 times input, and our input's 4, so that's what we put in for each one of these spots. And then you get 16 minus 12, which you know is 4. Same idea on the next one. Your rule is always the same according to what we have over there. And on all these, it's always input squared minus 3 times input. Now, it's just, once again, whatever's in your parentheses is what you plug in. So in this case, it's negative 2 squared, which is a positive 4, because a negative times a negative, plus 6, and you get 10. Now the next one is you're just putting in a triangle, so we just get this. So really, we can't do a whole lot other than maybe write it without parentheses. And then we have our input is squiggle. Really, it doesn't make a difference what is in our parentheses. Whatever it is what we put in for our variable. So really, that's what we're doing here on these 3 problems as we officially start section 1 of chapter 10. So that goes in. Your rule for this particular one is input squared and then plus 2, and then we're plugging in a negative 10. Well, you should remember a negative 10 times a negative 10 for the squaring would be a positive 100, and add your 10, you get 101. Why did I put plus 10? Sorry. We'll fix that. That's a plus 2, so you get 102. So over here, we have our new rule again. It's your input squared plus 5. Then once again, whatever's in your parentheses is your input, so that's what has to go in here. Now, remember that this whole thing squared means you gotta have to write it out twice, because squaring means multiplying by itself. And then we'd still have our plus 5, so we have to double distribute here. Our n times n, our n times our negative 3, and then we have to multiply out the inner terms here, negative 3n, do our last terms, get plus 9. Still with that plus 5 at the end, combine together any like terms we have, so we get a total of negative 6 of the n's plus 14 from our 9 and our 5. Over here, our rule that we have right here is input squared minus 5 times our input. Our input here is what's in our parentheses right here, so we put a negative 4x in each spot. And then we can do a little bit of simplifying. Our negative 4x times a negative 4x would be a 16, and then our x times x is an x squared. Our negative 5 times a negative 4x is a plus 20x. And when you're doing problems like this, you typically want to write it so you do not have any parentheses left. You may be tempted to try to pull something out here, but we don't want to do that. So write it without parentheses. So, couple of things. Polynomials are just several terms added or subtracted together. So what you're seeing here at the bottom of the page, these are referred to as polynomials. Now, your exponents have to be positive whole numbers, so it's just several terms added together with positive whole number exponents. So just be aware of that. Also, when we're talking about the degree, we're talking about the highest exponent that shows up. And so I highlighted those at the bottom of the page. When we're talking about our leading coefficient, you got to look at that term that has the highest power, and your leading coefficient is what's in front of that term. So that would be a negative 1 there, and then what's in front of this one, there's nothing written there, so that would be a positive 1. So just help you understand that. And then we need to go ahead and start talking about our end behavior. Now, your end behavior, it might be better if we go ahead and look at one. So we'll take a look at these here. Now, this is going to help us with our end behavior. anything that has an even degree, so that's your highest exponent, and happens to have a positive leading coefficient is going to be looking like this graph here, where it goes up going to as you go to the right, and it goes up as you go to the left. If it ends up being an even degree and a negative leading coefficient, that means you go down as you go to the right and you go down as you go to the left. So when we're talking about even degrees, I always think of a touchdown because a touchdown symbol goes up on both sides. So it's either a touchdown or an upside down touchdown. Now, when we're looking at an odd degree, so if your highest exponent was odd, it would look like this. And if your leading coefficient was positive, it would go up as you go to the right, and it would go down as you go to the left. Or if it was an odd degree but a negative leading coefficient, it would go down as you go to the right, and it would go up as you go to the left. So how do we actually write that? And well, that's what we have over here in red. It's always going to be represented like this. Now, this part right here, x approaches positive infinity. Well, x getting really, really, really big just means you're going far to the right on your graph. So this just means right here, what happens when you go far to the right on your graph? Does it go up or go down? Well, if it would go up, you would write this here, and then where that question mark is, you would put a little plus in front of your positive or infinity sign. If when you went to the right, it goes down, you'd put a little negative in front of your infinity sign where that question mark is. So pretty much what we have written over here in red is what you're always going to write. The only thing that's going to change is where you have that question mark, whether you're going up or going down. If you're going up, it's going to be a little plus for that question mark. If you're going down, it's going to be a little negative for that question mark. Now, just be aware that when we are looking at this right here, that's x. Now, x going towards negative infinity, that means you'd be going far to the left on your graph. So this just means going far to the left on your graph. When you go far to the left on your graph, does it go up like the lower left one here? Well, if it did, then you'd have a positive infinity in front of your infinity, or positive sign in front of your infinity. Or if it goes down like this one here, then you'd put a little negative in front of your infinity. So it's always going to be what we have in red. It's just what we do with that question mark that we adjust and change. And so if we go back here, that's what we're talking about for our end behavior here. By the way, when we look at this here, you're going up one way, going down the other way. I think of the 1970s with John Travolta doing the disco. So that's why it says doing the disco shape. So let's talk about our end behavior here. Now, from what we're looking at on that other page, we know that because it's an even degree, it's either like this, but it would be like this if it was a positive in front. So we know it's not that. Or it would have to be like this, which we know it's the case because we have our negative in front. So we're going to go ahead and write out our basic information. And then all we have to do is to go ahead and adjust what's going on in front of our infinity signs after the f of x. So as we are looking at this, this means as x goes towards positive infinity. So that means as you go to the right. So as you go to the right here, does your graph go up or go down? You can see the arrow on the red going down. So we would go ahead and put a negative in here. Now, when we're looking at this part, This means as x goes to negative infinity, remember x goes left and right, so that means it would be going far to the left, and you can see when we're going this way here, our graph goes down, so we would put also a negative here. So looking at this other one, we have a positive exponent of 3, so it's odd. So that means we know it has to be a discal. That's either like this one here, and this is what it would be if your leading coefficient is positive, which we have, or it would be kind of this one here. We know it's not the second one because this one right here is for when we have a negative in front, and we don't have that. So we have our basic graph up there. So I'm going to go ahead and write out everything that we need. Once again, when you're looking at end behavior, it's always going to be this statement, and all we have to do is adjust what's in front of those infinity signs after the f of x. So once again, x approaches positive infinity. That means as you go to the right, does your graph go up or down? And you can see that we go up. So we're going to put a little plus sign here. When we are looking at this, as x approaches negative infinity, that means as you go far to the left, and you can see in your graph that it goes down, so you're going to put a little negative infinity there. So that's what we're talking about for our end behavior.